So Daniel's just letting us know that we have 6 classes left together. And does that include today?
Yes.
So we got 5 after today. That's it, man. And so I just want to give you a perspective on where we're at. And so here are all the Bootcamp videos. And we're at day 16 out of, so this is week 4, basically, day 1, right? 5, 10, 15 would be the first 3 weeks. And then I'm changing it to day 16. And I'm going to put these all in one playlist on their own instead of like, each playlist is a day. But we're at part 2 of day 16, which there's a 3, 4, 5, 6, 7, 8, 9 on week 4, day 1. And then there's week 4, day 2, which has 1, 2, 3, 4, 5, 6, 7, 8. And then there's week 4, day 2, part 6. That's it, right? And so we have Monday and Tuesday, basically, boot camp, and we're partway in on Monday. And one of the most important pieces we're still going to learn and get out of these last 2 days of boot camp, or our last 6 days together, is we're going to see how to use Stripe and do payment processing. So well, cool, now I could build something that integrates payment processing. And again, you have all those code samples, which is another really important thing, is like getting the exposure, okay, and then I know where that code is, and I've seen how to use it, and now, okay, I want to put payment processing in. Let's go look at that example, see how they use that code, and then put that into my own project. Right, so that's one of the big things that's still coming. I'm really looking forward to. So that's what's on the docket, and then over the next 6 days together. And then also Daniel's working on, there's this place called, what's it called? DigitalOcean. DigitalOcean. And Daniel's like, I don't have a credit card. I'm like, all right, dude, I'll sign up. So I signed up, and Daniel's getting it figured out. And so the week after Thanksgiving, Daniel's going to take 2 days and teach us how to deploy a web app using Go on DigitalOcean, where you could basically,
They just give you a Linux machine.
Yeah,
That's
go
it.
ahead, talk about it, man.
They just give you a Linux machine, and that's it. So I'll be spending some time teaching SSH enough that you can connect, and then configuring up the Linux machine, setting up firewall and security, and then configuring it up so it'll boot your server automatically and let you actually connect. And then you can have your server do whatever you want. And then I'll spend a little bit of, if I've got time, I'll spend some time. I'll show how to get like a MongoDB installed or something, and so you got a database too.
Yeah, so Daniel's working real hard on that. He's going to present both days after Thanksgiving on using DigitalOcean to sort of do all that. So that's pretty cool. Looking forward to that. So we got some really great stuff left to take a look at, and so today I thought we'd just sort of, first of all, I'll show you the different things that we have working, and so we're going to look at Google Cloud Storage again. And you could do it with the PIMAuth, which is the deprecated way, and you could also do it using JSON authentication, which I did in both these examples. And then there's the movie website, which we looked at already, where you could do search, but then how do we upload an image for a poster or something like that? And so that's a use of basically using Google Cloud Storage, but here's like, okay, a little website where you can upload images and display them. And then there's a cool little program which lets you sort of call Web API and just display GIFs, animated GIFs. And then we have a what do they call it? Dun 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 dun. Mission Impossible. Thank you. We have a Mission Impossible self-destructing message, because in Bootcamp he wanted to show us give us a link to his auth file so that we could use it, but he didn't want everybody in the video to see that link, And so he thought, well, I'll create a self-destructing message where I could give you a URL. It'll then take you to show you that secret message, which would be the auth file. But then I could set how long does that exist for. So after a day, that message could blow up and be completely gone. So if anybody's watching the video, they'd never be able to get to that. And so we created a self-destructing message. And so that's sort of what's on the docket. I thought we'd start with HTTP Giphy, just because that's kind of fun to look at. And we'll just sort of look at the examples first, and you could see them working, and then we'll look at the code and start talking about the code a little bit. I should have done that. Why? I need to go into what? Am I not
CD
there?
First.
Oh, CD? What does CD stand for? What does that do? I know. I took an entire course on Linux terminal. It was pretty great. I remember about 8% of it.
That's usually about it.
But I was like, when I was taking it, I'm like, that's awesome. That's so awesome. That's so awesome. But I'm just not using it. Yeah. So localhost 8080. And I probably have to go to some unique path. What path I have to get GIF. And that one's got a little profanity in it, but it's kind of like they've synchronized it with his hands. My favorite one is this one right here. I don't know what happened to that cat. Mine moved on, used up one of its 7 lives. It actually looks like it's pretty high, right? It looks like that's a tower, and there's some treetops down below. So he's going for that ledge, but that was a little too slippery right there, and he's just like, man, you had a good life, I hope. I love the commitment, just full reach and dropping away. It's kind of sad. Right, so that's kind of fun. Somebody else had that one up there too. That's my favorite one. I have no idea what that's about. I guess it's some yoga pose.
The cat's doing it too. That's what it was.
Oh, the cat's doing it. This one's pretty great too. I don't know why I like watching cats fall. That's not tied down. And this one's pretty cool. Chases a bear away. That's one brave cat. So that's that one.
Does it randomize?
I don't know. I don't think so. It just pulls them. Though they look a little different than last night. So I think it's just whatever the... Because all we're doing here is we're searching for funny cat. And we're searching that API for funny cat. And we give it a key. And then we go and get that. And it gets back, results, client get. So URL fetch, which we use inside App Engine, create a client, and you can do client get, gives back result, body close. We have a struct, which mirrors kind of how they return data, except we don't completely fill it out. We just fill out the pieces we want, throws away any data that we aren't interested in, that we didn't have a field for or whatever. And then decoder put the results into that object, blah, 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 talking about code. And then print it out. That was a little bit fast. But did you follow it? Are we done with this one already?
We should probably look at the JSON so we can see how to decode that kind of thing.
Yeah.
Put that API URL into the web browser to see it in the JSON.
API URL into the web browser.
Put that into the web browser. Yeah. So most websites will have a help section for their API, which will tell you what URLs you need to go to, and then you can put it into your web browser to see what it's responding with. Just like here. And Todd's got a plugin JSON viewer for his Chrome, which makes the JSON readable like this. So
JSON view. Where do I see all my plugins? Settings?
probably.
Extensions. Accessibility, developer tools, App Engine, page speed, service preview. Secure search, I didn't know I had that. Google Docs, Google Hangouts, Google Sheets, Google Slides, HTML outliner, HTTP headers, JetBrains, IDE support, JSON view, live HTTP headers, NetBeans connector. I can get rid of that one. To hell with NetBeans. Postman REST client. Sweet, yeah, and then here's I put the link down here for the API. But this is kind of like Slack, right? Where you could, and here's how the sample search response. And so if you map that, that's kind of like the hardest part right there for me. If you map that, we have var object struct, and here we have the object, right? And then we have data, a slice of struct, and then we have data, and it's a slice, and there's going to be some structs in there. And then inside there we have data, slice of struct, and then so here's a struct, and then we have URL right here, right? URL right here, and we have images, which is a struct, images, right? So these are like the fields of that outer struct, and we have images, which is a struct, and then in images, right? I wish these would do curly like matching and be like, here's your ending match, but we have all these fields in there, which are structs.
JSON viewer
Does that?
or should at least.
And so then we go down to the original struct, which is at the bottom.
There it is.
Original, and then inside original we want this URL. Right, so just threw away all the other data, but that's kind of like mapping this craziness which comes back in JSON. I still don't totally feel 100% conversant with that, but mapping it to Go and then pulling it in. How many people think that's awesome? It's like, that's totally awesome. I think that's totally awesome. I'll put my hand up for that. There's 2 hands up. I see a few nods and smiles. And then, any questions about any of the rest of that? I guess we're just looking at one and actually looking at this example. It's a pretty easy one to go through. Take a moment to take it in.
So you have to go through URL fetch. You can't just use go's http.get. App Engine will block that. But URL fetch library basically gives you the same thing. URL fetch.client, pass the context. I believe that will make it run off of another server on Google, which will then sanitize it in case that you get back bad data or whatever. So you don't have to worry about a variety of different attacks. It'll deal with man-in-the-middle attacks and all that too.
That'll be useful.
Yeah.
Isn't that a Michael Jackson song? Talking about the man in the middle. What, man in the mirror, that's it. Man in the mirror. Anybody want to see this right here? Client context, HTTP client, and URL fetch. Client context, URL fetch, the package right there. It's part of App Engine, URL fetch. So let's go look at that. Go doc. App Engine. App Engine. URL fetch. Provides HTTP round trip implementation for fetching URLs via App Engine's URL fetch service. And URL fetch, and then we get a client, and it returns an HTTP client. And when we have an HTTP client, what can we do? So HTTP client is an HTTP client. We have transport, check, redirect, jar, timeout. But then we also have these methods: do, get, head, post. And so we were using get a client and then do client get. And so client get is get to a specified URL and gives us a response and an error. And then response is net HTTP response. And so in response we have body, which we can then get out what the response was. And so that's kind of what we had, get a client. And then we could use get, that's one of the methods associated with client. And then that gives us a result, and the result has a body. Right, so we defer the close on that, and then we get that result body and then decode it into our object. So encode, decode were for like capturing streams with JSON, and marshal, unmarshal are just like I'm just doing it with a string, not a stream. Right, like here's a string that I've got somewhere in my program. That's how I say that. Does that sound right?
Yes.
Okay, cool. You guys have a few more years of comp sci on me. All right, so that's a HP Giphy, pretty fun. Self-destructing message is pretty quick, so we'll look at that. And let's just see where do I have to go in my routing. Slash, and then I can have that at message. And to run that, Control C, CD, 62, go app serve, and no app 01. The little details which the little gotchas in life, right? Sometimes the most obvious things, like I was totally wet this morning, just got out of the shower, like dripping wet, and I thought, oh, the hairdryer's plugged in, that's a hazard. So I reached over and unplugged it, and I was like, that was really dumb. I'm totally wet. Unplug the hairdryer. Those are the things which close tabs to the right. And I can put in a message. Here is a secret message, and you can see I can't spell. There we go. Submit. And it gives me this. Here's so that is my message ID, but it's also a link. So I could copy that link address, right? And if I paste it, right, it's a link going to message ... right? So I could send that crypto message to somebody, or that string right there, that unique ID right there, and then they could come and drop it into this URL and read the message. And once the message has been read, like I'm intentionally waiting here a little bit because the timeout on the message, it's not like the timer started as soon as I created the message. So as soon as I view the message, it's like Mission Impossible. You open the message, this message will now self-destruct in 10 seconds. Right? So that message is going to persist we set that in memcache. In memcache for as long as memcache exists. Right? And memcache could get cleared out. So maybe we do this at a data store if we want it to be longer term. And but then once that message is viewed, so now I'll go view that message, and here's a secret message, and you can see I can't spell, and I can hit refresh, and it's still there. However, after 10 seconds, right, and we're probably pretty close to that. Boom. Dun 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 dun. Doo doo. So, sorry, I annoy myself too. It's not just you. App YAML, straightforward, and then the idea on this is go here, and so we're going to have if request method is post, and then that's going to go right to here. So if it's some other method other than post, right? So if it's a get, then we want to give a form in which to submit a message, right? So that's sort of that conditional logic. And then if it's post coming in, then we want to handle the form submission. And so the form submission is going to get from our form submission the value message, and that message comes from right here. Name is message, and so then we get our message, and we get a new UUID, and then we go to memcache and we store the UUID, and we store our message, and we create an item, and then here we're storing it in memcache, and then we write out our string, right? Our response, and we could use IO write string, and this is probably review for everybody in here, but I'll just say it because write string wants right here a writer, and so we're giving it a writer, the response, and response writer implements write. So we're using write string to write our response, and there's our response, and we're putting a link here, which goes to that URL with the key. And then we're also just printing out the text of the key in case you want to copy that and send it to somebody. And this is actually a really powerful example, and I'm going to show you why in just a second. Like this is like production level, full scale, what the NSA does not want terrorists to have, right? Like if we were to deploy this and say terrorists communicate securely, they would never use it probably, because they'd be like, that's a trap. But if they knew this code, or if they saw this code and went and got this code and deployed it themselves on, however they did that, so maybe DigitalOcean, right? Something that's secure from even if the NSA had access, if they deployed this is totally like nobody can get into. Well, this one they can, but when we get here to the crypto, that's 100% locked down. There's like no reading those messages. Put a message up, send somebody that unique ID, they get to see the message is gone. And there's no unwinding the message. It's AES, which is like military grade encryption, if I'm remembering exactly how it was built, because we used something slightly different than AES, but I think AES was part of it. Do you remember?
I don't remember.
You don't remember. All right, so anyhow, that's just like an interesting commentary in light of recent events with, the Paris stuff, and they're talking about, hey, these apps that allow you to communicate with encryption, they're questioning having those. All right, so that's that, and then what happens with our message? We get a context, and then we basically are pulling out that key, and so split in. If you look at string split, I kind of I guess split in is fine, but godoc, I've already got godoc up here. Strings. And we have a couple of splits. We got split, split after in, and split in. So split in slices S, so you give it a string, you give it the separator, and then you give it how many times you want it, the separator to slice it up, right? And so split in slices S into substrings separated by the separator and returns a slice of the substrings between those separators. If sep is empty, split in splits after each UTF-8 sequence, so that would give me characters, is that right?
Yep.
And runes, give me runes.
You know, it's not giving you runes. Runes is a single byte. It's giving you the full UTF-8 character separated
Oh,
out.
is a rune a single byte? I thought a rune was a character. A rune's an N32, you're right, it's a single byte, so it's giving me the full UTF. So it's giving me the character. You're right, man, good distinction. I love that. The count determines the number of substrings to return. So that's split in, and then there's split, which, you know, it just separates on all the separators. And so split in here, we're saying split on 3. And so if we look at that URL, if we look at that URL, right, it's gonna start right here. And so this will be the first one is basically right there. That's the first thing we get back, except it's an empty string. This is the second one we get back. This is the third. And so all this stuff. And so when we say split on 3, we're getting 3 things. 1, 2, 3. And if we had more forward slashes, you know, that would be part of the third one because we're only splitting on 3. Is that right?
Yes.
And
that's why we're using split then, instead of just plain split.
yeah, but it's talking about not how many separators split on, but how many things to return. So we're splitting on 2 to get back 3. And then we're saying, give me what's in index position 2, 0, 1, 2, so the third item. And that gives us our key. And then we, I wonder if, I just have to look at my message again. I just searched for it. That was not what I was looking
You get
for.
a space after the slash.
Do I still have space after the slash?
It's gone now.
There we go. I'm sorry. It amuses me. Memcache get context and key give us back an item. And then there's inside items, and Daniel is the one who figured this out at Bootcamp. This was totally awesome. So if you want us to talk about it?
Yeah.
No. If we look at godoc.org and Golang App Engine. Like, I totally love that I feel completely comfortable with this and know my way around this place now. It's like, oh, we need to go look. That's where we go find the doc. I used to be like, golang.org, godoc.org, where's the App Engine documentation? It's like all right there. So if we look at item has, and this is the thing that is interesting. Flags are server opaque flags whose semantics are entirely up to the App Engine app. Like when you read that, what's that mean to you? How many people read that and they're like, I'm not totally sure. Flags are server opaque flags whose semantics are entirely up to the App Engine app. Like that's like some other language for me 6 months ago. Like what does that mean? So what's it mean? Who feels like they could explain it? What's server opaque? What's opaque? Can't see through it, right? Server opaque. So the server doesn't really look into this stuff. So the App Engine server is not looking into this stuff. It's entirely up to the App Engine app. That's us. We're creating an App Engine app. This is my app. And the server doesn't care about this stuff. It's opaque to the server. Is that right?
Yep. And
That's
semantics is meaning. So.
Yeah, and semantics is meaning. So flags are App Engine, the server doesn't care. They're opaque to us. We don't care. Just like context is opaque to us, the developers, you know, and it's not opaque to the server, right? Like the server knows what's inside there and uses it. We don't, you know. So these are server opaque flags whose meaning, right, is entirely up to us. So we get to define the meaning. And so over here, we set a meaning for a flag. And we said, hey, the flag, first time through, just defaults to 0 value, which is 0, because this is uint32, so the 0 value of that is 0. So hey, if this is the first time through, this is going to run. And then we're going to set the flag to 1, and we're going to set expiration. Why did we do this? Why this chunk of code?
So that it doesn't expire until someone uses it.
So that they can't just keep hitting refresh and resetting the timer. This message will self-destruct in 5 seconds, refresh. This message will self-destruct in 5 seconds from now, refresh. This message will, and they can do that forever, right? Like, I don't want this message to go away. I got to go down the hall and show somebody. They can just keep hitting refresh over and over. And of course, they could take a screenshot. So that's the flags, and you could do bitwise operations on here. Is that right?
Yep.
You could set like different. It gets complicated at that point. So you could have all kinds of things, different flags in there, right?
Yeah.
I don't understand that. And then we just write our response back. Response, write item value. What's item value? Item mcache get value. So we're writing the key. No, we're writing this item, that item with.
You're writing the message back to the response.
Writing the message back to the response. Oh, right. Got it. Okay, so that's where we actually display the message. Cool. That's that one.
You wanted to show the number 2 with the crypto?
Yeah, and so for the Google Cloud Storage, I'm going to start a new video. And
I mean the self-destructing message too, crypto.
oh, crypto, self-destructing messages too. Yeah, so that gets a little bit more involved. Here's the crypto. So encrypt, decrypt, and then all this stuff down here, which we have handle index and message, right? So we have handle index. That's all exactly the same. And handle message, that's all exactly the same, except now we're funneling it all through encrypt, decrypt. Somebody enters a message, we encrypt it, we stick it into memcache, and then we pull it out of memcache and we decrypt it. And to encrypt it, we create a one-time number. And I don't totally understand this stuff. I don't understand this stuff.
Security is complicated.
Security is complicated. We create but basically it's coming from this secret box seal. Well, what is secret box? What is that package? Here's the package. And it's golang.org x crypto NaCl secret box. NaCl is sodium chloride, which is salt. And so you hear about salting cryptography, right? So that's kind of cool, you know. Like crypto is crypto. People in crypto are all crypto. And this X package stuff, I read about that in the new book that came out by Donovan. So you could search Amazon Donovan and Kernighan, and they have a great book on Go. And the X package, they say, is stuff that is in development, which it's developed by the team at Google, things in the X package. And they are packages that are in development and might eventually move to the standard library, or they're just things that Google built that they use, which will never come over to the standard library, but they're making them available to us. And they don't, for whatever reason, they're saying it shouldn't be in the standard library, but it's still available. So if we go and we look at that package, golang.org secret box. Package secret box encrypts and authenticates small messages. Secret box uses X-Salsa20 and Poly 1305 to encrypt and authenticate messages with secret key cryptography. The length of message is not hidden. It is the caller's responsibility to ensure the uniqueness of nonces. So it's a one-time number, that's a nonce. For example, by using nonce 1 for the first message, nonce 2 for the second message, nonces are long enough that randomly generated nonces have negligible risk of collision. And you have to use a one-time number, because if you don't, then you could somehow backwards engineer like how it was all built and break it. And so that's like when Sony PlayStation got hacked. They'd done everything correctly, except they hadn't used a one-time only number. They'd used the same number over and over, I guess, to salt it or seed it. And I don't know if I'm saying that right. But and then when they did that, you know, it was able to be cracked because they didn't use a nonce. They just used a number over and over. And so we have here, we're secret box seal. So read at least, I'm not totally sure. Do you know what that line does right there? Because we create slice 24 bytes. But anyhow, I don't want to go too much into the crypto thing. You could look at it. And the reason I want to go into it is because I don't know it fully enough to explain it well. But so this code was like Caleb code, and you can look through it on your own time. Let's see how Google Cloud Storage works. How's that? Anybody want to say anything or ask any questions about all of this? No contributions to it? Cool, we're done with it. All right, so the next video we'll look at Google Cloud Storage.